So this is the third problem which we are going to discuss related to equivalent inductance of a circuit. So here this circuit is not that straightforward, okay. It is not that straightforward. For a beginner to network theory or basic electrical engineering, this circuit can create a little bit of confusion. If you are just getting started with the basic concepts related to network theory and basic electrical engineering, this can create a little bit of confusion. Now, what will create confusion is these shorted terminals, okay, these shorted terminals. So a student will be confused as to where to begin or where to start solving the circuit, how to identify the pattern, that is which inductors are connected in series, which are in parallel. It will be a little bit difficult to identify. So as we did in the resistors case, calculation of equivalent resistance, where shorted terminals were there, where two terminals or 2 points, okay, 2 points, they were shorted, okay, they were shorted. We used an approach that is to name the terminals, to name the points, okay. So here also we will name the points 1, 2, okay, let's name it 3, okay. Now this terminal is shorted with here at this point and this point, they are shorted. It means this will also be 3. This point and this point, they are shorted together. It means this point is also 3. Now the circuit has become little bit simple for analysis. How? Let's see. Okay, now you look at the inductances which are connected between 2 points. Between point 1 and 2, we have this inductance 1 Henry connected. Okay, by the way, we have to calculate the equivalent inductance between point 1 and 2. This is the question. We have to find out the equivalent inductance in between point 1 and 2. Okay, this is the question. I just forgot to mention it. Okay, so we have to calculate the inductance between these 2 points 1 and 2. We just named them. So now between 1 and 2, we have the 1 Henry inductance connected. Between 1 and 3, we have this 1 Henry connected, and also between 1 and 3, we have this 2 Henry connected. Okay, so let us just draw it. Okay, this is 1, this is 2, this is 1 Henry. Now between 1 and 3, okay, we have 1 Henry and 2 Henry. So let us just extend this terminal, okay, and let us just say that in between 1 and 3, okay, we have this 1 Henry and this 2 Henry connected. Okay, so let us just do it. So we will take this point here. For easier analysis, we will take this point, let's say here. We will not take it here, we will go as per this circuit. Okay, we will take, let's say, this point here, 3. Okay, so in between 1 and 3, we have two inductances, 1 Henry and 2 Henry, that are connected. Okay, this is 1 Henry and this is 2 Henry. Okay, now in between points 2 and 3, in between points 2 and 3, we have 1 Henry and 2 Henry. So there are two inductors which are connected. It means the 2 Henry and 1 Henry, they are connected in parallel across 2 and 3. So first we have this 1 Henry and then we have this 2 Henry, 1 Henry and 2 Henry. So now we have to calculate the equivalent inductance between 1 and 2. Okay. Now the equivalent inductance of this combination, okay, this combination between 1 and 3, okay, L 1 and 3 is equal to 2 into 1 by 2 plus 1, which is equal to 2 by 3. Also, the equivalent inductance between points 2 and 3 is equal to 2 into 1 by 2 plus 1, which is equal to 2 by 3 Henry. Okay, 2 by 3 Henry. So we can just reduce this circuit diagram as this. This is 2 by 3 Henry. This is also 2 by 3 Henry. Now these two inductors, sorry, L13 and L23, they are connected in series. So the equivalent inductance of this combination, these two inductors, okay, which are connected between points 1 and 3 and 2 and 3, will be simply the addition. Equivalent inductance will be 2 by 3 plus 2 by 3, which will be simple 4 by 3 Henry. Okay. So the total inductance, now we can simplify it, it will be 4 by 3 Henry. Okay, 4 by 3 Henry. So now this 1 Henry and 4 by 3 Henry, they are connected in parallel across the points 1 and 2. So L12 will now be the parallel equivalent inductance of 4 by 3 Henry and 1 Henry, which will be 4 by 3 into 1 by 4 by 3 plus 1, which is equal to 4 by 3 by 7 by 3, which is equal to 3 gets cancelled, 4 by 7 Henry. So the equivalent inductance between points 1 and 2, which we are supposed to calculate, is 4 by 7 Henry. Okay, so the thing which can create confusion is this shorted terminals. Okay, this shorted terminals. Now this can create confusion in the mind of a student, a beginner, as to, it will create difficulty in identifying the pattern of connection. Okay, here she will be she will be not able to determine which groups of inductors are connected in series and which inductors, a combination of inductors, they are connected in parallel. So the smart thing to do is to name the terminals. Okay, name the terminals. So here we name the terminals as 1, 2, 3, as these 2 points were shorted. So this point will also be 3, as these 2 points are shorted. So this points will also be 3. Next thing to determine is to which inductors are connected in between the 2 points. Okay, so we found out that in between point 1 and 2, 1 Henry is connected. Then in between points 1 and 3, there are 2 inductors, okay, which are connected between the same 2 points. It means they are connected in parallel. Similarly, between 2 and 3, there are also 2 inductors, 1 Henry and 2 Henry, which are connected. It means they are connected in parallel. So next thing is just simply to solve the circuit, and by utilizing the various parallel and series equivalent inductance formula, and to find out the total inductance. Okay, so this is the third problem which we discussed related to equivalent inductance calculation.